One of the things in vectors that's kind of confusing to understand is when we get these types of questions, students usually ask, but uh, why am I taking a longer route? Why don't I just write P to Q? Why do I have to do this negative A plus B kind of stuff? What's happening? So in this video, I'm going to try and explain that. I'm going to start off really easy with something like a rectangle. If I had a rectangle and I had the side length 10 and 20, and I asked you work out the area, then you'd say, well, I have the numbers. I can just say 10 times 20. And if these were meters, for example, then I would have something like 200 square meters and I'd be happy. But if I had a similar shape and I wanted to find a rule or a representation of the area for a similar shape, I would say, okay, well, this side is maybe x and that side is 2x. So as a rule or as an expression or in terms of x, I could say x times 2x for the area, and that would be 2x squared. And this is then not a number, but it's a representation or an expression of how to get the area of this shape. Now, having that in mind, I'm going to quickly do a kind of, I'm going to do an example here. So let's say we're working with a vector, and usually position vectors, or I'm going to say it's a position vector. So I start with the origin, and my vector is going to go in that direction. And I'm going to go from the origin to a point A. And this point A, I'm just going to give it some coordinates. It's 4 and 6 on a Cartesian plane. And I'm going to write a vector. Okay. If I wanted to write this as if I wanted to write A as a column vector, then I'd say, well, I started at the origin and I moved 4 units forward. So there's going to be a 4 there. And I moved 6 units up. So as a column vector, that's what it looks like. I can also say, well, I'm going OA from O to A, and I'm going from O to A. So this is kind of all the same thing, but I have actual numbers, just like there I had actual numbers. For the next one, I'm going to do, let's say I'm going to go in that direction. From the origin, I'm going to move to my point B, and my point B, I'm giving it a coordinate 10 and 2. And I just want to keep the color coding the same. Okay, let's say that is that's B. So for B, if I wanted to write this as a column vector, I started at 0, 0. So I went 10 forward. So that's 10. And I went 2 up. So that's 2. And I can also express it as OB. Very important. I'm showing the direction, OB. Now, I have the numbers. So if I wanted to find out, for example, what's AB, AB, if I wanted to find that, okay, let's say that's a point and that's a point, and I want to go there in that direction. Let's call this C. I have the actual numbers, so I should be able to work this out. Because I went from 4 to 10, so I moved forward by 6, and I went from 6 down to 2, so I went 4 down, so minus 4. So this is that little thing there. I could do this from A to B directly because I have the coordinates for A and the coordinates for B, and there was no problem, so nothing weird about it. But I could actually use a different path. I could say, if I wanted to go from A to B, I could follow a different route. Instead of going directly, I can walk like a detour. I can go from A to O, so A to O, and then once I'm there, I can say, well, I'm going to go O to B. So I know that if vectors, if I add them together and the starting point is the same and the ending point is the same, and I simplify them, it should kind of work out to being the same thing. So what does that mean? For this one, AO is the opposite direction of A. So it's not going to be A, it's going to be the opposite direction. So it has to be negative A. And then this B is in the same direction, so that's B. Now, usually this is kind of where we end when we talk in the vectors and the exams, and this is what they want. But I just want to prove to you what we're actually doing. So I know A is 4, 6, but it's a negative A. So there's a negative 4 and 6, and there's a plus B, which is 10 and 2. So 10 and 2. And then we can see something weird happened. Well, not weird, it's just like, oh, cool. Minus 4 plus 10, that would give me 6. And minus 6 plus 2 would give me minus 4. And wow, can you believe it? It's actually the same thing. So we got 6 and minus 4. So even though we took a longer route, by adding these vectors together, we got to this point. So in the past paper examples that they give us, they're just kind of asking us, in terms of A and B, how do we get from A to B? Just like in this example, I'm saying, in terms of X, how would I work out the area? I don't have the numbers, but I have these weird vectors and I can follow different paths. So that's kind of what we're doing. We usually end off there. The other thing that they usually ask is midpoints. So let's say I drew a little line. Okay, let's just do this. To make a little line there. And I said, well, I want to find the midpoint. I'm going to call the midpoint M. If I wanted to find the point M as a coordinate, so let's say the point M I want as a coordinate, you'd say, well, that's easy. It's the midpoint. So how do we find the midpoint? We just take the X value plus that X value and we divide it by 2. So 4 plus 10 is 14 and we divide by 2. So that should give me 7. I can actually write it there. That's 7. And if I wanted to find the midpoint between the 6 and the 2, then I add them together. So 6 plus 2, that would give me 8. And then divide that by 2, and that would give me 4. So that is the midpoint as an actual coordinate. But what if I didn't have those coordinates? So the midpoint is, obviously it's halfway. So that's a half. And that's a half. Sorry if you can't see it. I know that's very small, but it's kind of, if I go from A to B, M is going to be halfway there. So if I wanted to find a type of question that they might ask us is, hey, find OM as a position vector. Let me just kind of make a little block here. Where are we going to do it? So let's going to try and do it in that block. So if I wanted to find OM, that is the same as going from O to A. So O to A plus I'm going halfway from A to B. So halfway from A to B. So if I did it, if I use the actual numbers, right? So I know OA is this A, which is this 4, 6 thing. So we can do 4, 6 plus half. We worked out AB as 6, negative 4, right? So half of 6, negative 4. So let's see where we end up. Sorry, I could have just wrote that there. Let's see where we end off. If I have 4 plus the half of 6, half of 6 is 3, plus 4 is going to be 7. And if I have half of negative 4 is going to be negative 2, and that negative 2 plus the 4 should give me negative 4. So you can see it kind of, we get to the same thing by following the two vectors together. If I wanted to write it algebraically, I could go the route and say, well, OA is A, and then AM is half of A, well, let's say C. It's half of C. But maybe I didn't have C. So then I'd have to say, well, I don't have C. I just have half of, I know it's half of AB. And then sorry, I'm going to move it up a little bit. So I don't necessarily have AB, but I know AB is going from there to there. So AB is actually negative A plus B. Negative A plus B. And if I distribute this, sorry, I'm going to need some more space. If I distribute this, then I have a half times negative A is minus a half A, and a half times plus B is half of B. Okay, we should do these little things underneath. And A minus a half A is just half an A plus of B. Oh, sorry, half B. And if I have this actually, well, okay, this is where we should end. This is kind of what they want. But I can see if I sub in these values, I should get to the same value. So half of A, which was 4 over 6, plus half of B, which was 10 over 2. So this would be 4 plus 5. Sorry, not 4. This is half of 4, so it's 2 plus 5, which is 7. And then half of 6, which is 3, plus 1, is going to be 4. So I can see this 7, 4 is, I mean, we're trying to find this position vector, right? So the position vector to go from O to M, if I wanted to go directly there, it's 7, 4. So which would make sense because the coordinate is 7, 4. So from 0, I had to move 7 forward, which is that 7, and I had to move 4 up, which is that 4. So I can see all of this stuff is kind of just algebraic substitutions to show what something will be like if I don't have actual values. That's why we're following different routes, is because we don't have that or that or that. We actually only have these little vector things, and we know that combining them in certain ways that we can find different routes and actually express a different route maybe in terms of A of B. I hope that makes sense. In the next video, I'll do a couple of examples of past paper questions that we can just solidify this. But this is just kind of the background of why we follow the weird paths we do.